Hello everyone, today is the 12th day of Leetcode 75 challenge. Let's begin with the 12th question. Question 11. Container with most water. Level of the problem is medium. I will request you to read the problem beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in easiest way possible. Okay, you are given an integer array of height, okay fine, which is of length n. We need to find two lines I and j that form a container with the x-axis. A container means what? A container is formed by two lines at the indices I and j and the x-axis within I and j. Okay. The amount of water it can store is determined by the shorter height of the two lines and the distance between them. So this is basically the concept of calculating the water or the surface area which will be stored in the water. So basically which one is the shorter from there, we will take that as the height and the distance between them, and from there we will get the area of the, or we could say the surface area where the water will be stored. Now our task is to find two lines that maximize the amount of water stored and return the maximum water possible. I hope you understood the problem explanation. Now let's understand the constraints. What is n? N is the length of the height array, and n could be from 2 to 10 to the power 5, and height could be from 0 to 10 to the power 4. So these are the constraints given to us, and this is the problem explanation. And now let's move to the next slide. Let's understand the input output of the problem. So this is what is given to us, and this is the height array. Now output is 49. How? Okay. So as you can understand, you have to find the area between any two indexes. Okay. If you take I and 7, then length between them is 3, 3, 6, 7. So 7 into 1. Why 1? Because the minimum height is 1 here. If you understand, if this is the thing and this is another pole, so you cannot take this one because the water will fall out from this side, right? So keeping that in mind, we have to take the smaller one so that water is within the surface area itself. Okay, then this does not work, so we will cut this. Then we could try going with coming here and taking this one. So out of this 7 and 8, we know that 7 is smaller and distance between them will be 3, 3, 6 and 7, right? Sorry, here it will be 8 and this is 7. So it will be 49. Oh, okay. So we got the output. Now another try which you can do is taking distance between, um, let's take between 7 and 5, right? Let it be 7 because let it be 5, not 7. It will be 5 multiplied by 4. What we get? We get 20. Okay. So you're getting this point, right? This is the minimum height compared to both 5 and 7, and the distance between them 7. So basically what we are doing length into breadth in this case. That's all. Find in the area of rectangle. So I hope you understood this problem, and we got 49 from here. And if you do the calculation of multiple times by taking, let's say, 2 and 5, we take 2 into 1, so we get 1. Then we could take 6 and 4, 4 into 3, we get 4 into 3 gives me 12. So if we calculate all the different pairs, then we will get to understand that 49 is only the output, correct output, which is between 8 and 7. Now let's look into the second example. There is nothing. We are given two values, 1 and 1. So either of them is similar, right? So we could take any of them, and 1 is there, and distance between them is also 1. So we get as 1 as the output, right? I hope you understood the input output explanation. Now let's move to the next slide. To understand the problem, what it is asking, we should build up an intuition to the problem. Okay. Imagine you're building a water tank between two poles. Let's also keep on drawing it. This is one pole and this is one pole. Okay. You have a road marked with different heights at regular intervals, like an array of pole heights. You want to build a tank between two poles to hold the maximum water. So they are saying that you have a road here, and each road in the road there is in each interval, like this interval and this again interval, they have mentioned the height of the pole which we can use. Okay, if we can use 6 here, then let's say they are saying we can use 8 here, then here we can use 2, then here we can use 4. So they have mentioned the height, like where we can use which one, right? Okay, so this is understand. Now you start picking up the two poles at the ends of the roads is that gives the widest space. Okay, so what foremost things comes to our mind? Okay, we are being given an array or we have a road, and in road in each interval we have given that we go to this length or height of the pole here, right? Okay, but first thing which comes to our mind is that if we take the widest distance, like if you take the leftmost beginning one, rightmost which is there, and then we get some value between this length could be, let it be x, and out of these two if you take 8, okay, it does not make sense because 8 is greater, so 6 plus 2 gives me 8, right? So we have two values of gap here, so water will spill out. Fine. So keeping that in mind, what we will do, we will take 6. Okay, if we take 6, we get a value y. Okay, this is the area which in which we will be storing the water. Fine. Okay, but this is not it, right? This is one of the intuition that we could take the widest part, but now we don't know whether the coming upcoming poles area or the intervals could have the height of maximum height also compared to the previous one, right? So the amount of water you can hold depends on the shorter pole, as I explained. Because if one pole is shorter, the water will spill from that side, right? Which I explained here. If we are taking 8, then there will be two gap remained for the 6, right? The water will spill out from here. Okay. Now other thing. Now to increase the water capacity, what comes to our mind in the second thought? We could try adjusting the poles. Fine. So let me remove this. We could try it by doing the adjusting the pole. Fine. That is the rule. Consider this at the height of the poles. Okay. This one, this, this, and this. Okay, let it be much more bigger than this. Let it be small. Let it be doing something like this. And yeah. So these are the poles given to us. Okay. Now, but first our intuition was we take the leftmost and the rightmost pole and minimum from any of them between the two and multiply with the length of the rope. Okay, that is understandable. After that, we could see that there are multiple rods after the first and after, before the last one, right? We can see here this pole, this one is big, and in upcoming here we can say this is the tallest pole, right? Now we know that if it is a value of 7 and this is a value of 12, we will take 7, right? And this will cover this poles, right? Now what? For example, if you take 1, 2, if you take 1, 2, 3, 4, 5, 6, 7, 8, okay, 8. So we could say 8 is the length between them, distance between them, and 7 is the height. So we get 56. Okay, so what else you understood? Not by only assuming that taking the beginning pole and the last pole could give us the best answer. There could be multiple cases if we check if the length of the pole is greater compared to the previous ones, right? So this is one of the output which we got. Now what else? Now we can see that this is the pole which is longest in our case till now compared to both, right? So there could be a chance if we thought it more intuitively. There is a pole of length 7 and there is a pole of length 12. So there could be a chance that there is a pole which could be greater than 7, which could be greater than 7, not mandatorily, it will be greater than 7. Since we can see that one pole is there of which is shorter than this, then which is between this and this pole, right? But if we see there is one more pole here, this one, right? And let it be length of 9. Fine. Okay. So what we can do? We can just try using this pole length and the previous pole length on the right side which is 12 and take out the answer, right? So if you do 9 multiplied by 1, 2, 3, 4, 5, okay, we get 45. Okay. So in this case, we can see that we got 45, but it is smaller than 56, right? But why? We have the longest pole of length 9 compared to the 7, right? But you also have to understand that the distance is also getting reduced from both ends. Fine. So we have to keep in mind that the distance would also be of a understandable length, and the pole length also have we have to look at that which one is smaller and which one is greater. Now we won't be knowing what is coming after the pole with the right hand side and the left hand side. So once we got 56, we should store it somewhere, right? So that when we get another value like just now we got 45, assuming that 9 was bigger than 7. So here we could see that 56 is greater than 45. So 56 remains our answer again. So this is how our intuition works. First thing comes up that we check for the first and the last pole values and multiply the distance. Then we have another intuition thought that let's move forward in this direction since this side is the smaller one, and we found that there is another pole of length 7 greater than this pole. We did the multiplication and we got 56. Again, we had in mind that let's move more further so that we could get more bigger pole. We got the bigger pole here, but the distance and the surface area comes out to be smaller. Now there could be another case in which right hand side pole could be smaller compared to the left hand side pole. So what we will think? We will think of moving this to the left hand side. So this same scenario may rise up again, right? So this could be our intuition to work upon. So as I've written, if the pole is shorter, you move it inward, hoping to find a taller pole that can hold more water, right? If the pole is shorter, you move it inward for the same reason again. Okay, from both left and right. Our goal is to keep adjusting the pole until we find a combination that creates the largest possible tank. So I hope you understand the intuition why we have to keep on checking on the poles from both left and right side, right? And taking the distance between them. So from here, you can also put out another thought that we're using two pointers case here. Since you're moving from left to right and right to left, and we have poles in left and right, and we have to find a surface area between them. So it should come to your mind, or it should be understandable till now that we are talking about two pointers here. And this is what we will be implementing in our approach coming further. I hope you understood the intuition much clearly now. Now let's move to the next slide. Before going to the approach, let's understand what this two pointer concept is. Two pointer is a technique where we use two different variables, which will be pointers obviously, and to traverse an array, string, or linked list efficiently instead of using nested loops. Okay, how it works? You place two pointers at different position. The common one is starting position of the array and the ending position of the array. Okay, move the pointers towards each other in a specific direction based on the conditions. So you have to move pointers to each other based on the conditions where they're going to be terminated. And this also helps in reducing the complexity from of n squared to n. So there could be some conditions in which, let me be more clear to you. There could be conditions where we are traversing in O of n scenario, right? For loop is there and another for loop is within it, right? But if we have to convert that n square approach to O of n, we could use two pointer in that case. If this is the array, right? We could place I here, and we can start j from here or from here also, or from here also. It is not mandatory that always j and I will start from start and end. The position could be anywhere. But the thing is that it should work in such a way that it reduces the complexity from O of n square to O of n. There could be one more case like this. You're starting from here and going this side and this side, right? So this is what this two pointer is all about. Basically, we try to convert O of n square to O of n, first thing. Second thing, if we have any question like where traversing in a single point is manageable, we use two pointer there. And places where we use two pointers could be sorting and searching when dealing with sorted arrays to optimize search operations, linked list for detecting cycles. Here we use the concept of fast and slow pointers, which we will study when we solve the questions based on linked list, and finding the middle or reversing efficiently. In string manipulation, when modifying or comparing or checking conditions on a string, in sliding window is the most important one to use two pointers for finding sub-arrays or substrings for specific properties. Two arrays processing, which we are doing right now, when merging, comparing, or finding intersections of arrays, and greedy and optimize when solving problems that require scanning from both ends. As I said, we can go from here from start and beginning. Okay. I hope you understand why we are using two pointer concept and how it is done. Let me give you one more small example. Like if we have this sorted array and we have to find some, say, five, right? Not five. Let it be four, and let it be five. Okay. Now we are asked to find a value as 2 plus 5, 7, right? Okay, we have to find 7. Optimized way using two pointer would be we will start from start and one from beginning. We add these two values, we get 6. So from here we could understand that 6 is less than 7. So what we will try to do, try to move the left pointer towards right. 2 plus 5 we get 7, so we got our output. And this could be same done in the O of n square opportunity complexity by traversing start keeping index 1 and traversing this complete array, then keeping this as 1 and traversing this complete part. So yeah, so this is one of the examples I could take right now for understanding of the two-point concept. I hope you understood it now very clearly. Now let's move to the next slide. Since we got the intuition of the problem, let's look at the approach how we gonna solve it. Okay. Now we define variables. Okay. One would be n of length height, and we have to declare two pointers. One will start from 0, other will start from the last. Okay, n minus 1. Now we are storing here in maxi variable float of infinity, negative infinity, because we have to store a maximum value, right? So we cannot put a positive value in the infinity. So we cannot put a positive value in maxi, right? So what we try doing, we try putting negative value, the most negative value. So always keep in mind when we have to find a minimum among everything, we put positive value there, a positive infinity. Or if we have to find the minimum of all, sorry, if we have to find the maximum of all, then we try to put the negative value or negative infinity to it. So as soon as we strike the first value, which is greater than this, we can store it there and keep on comparing. Similarly, if we find a value which is smaller than this, we store it there and keep on comparing, right? So that is the reason whenever there is a question which requires finding maximum and minimum, please store the vice versa infinity values in those so that it is written here to initialize the smallest possible value. So any valid area will be larger for it. Okay. Now, why two pointers? As I already explained you in the intuition, I will try to explain it again. First and foremost things, we have to find the area distance between any two pointers, right, or poles. And also two pointers help the explore largest possible distance because Since we have to find the distance between the poles also, we can directly do j minus I to find the distance between them and giving a greater chance of maximizing the area. Now, by adjusting the shorter height, we try to increase the minimum height, right? And the maximum area. But it means that if it is a minimum height here, so if we go further, we try to find a maximum height compared to the previous one, and this could also may result in finding a greater area. Okay, and it also helps in reducing the n square approach directly to O n approach, right? So these are the reasons why we are using two pointers. Along with it, from our intuition, we got to understand that using two pointer is the most viable and most efficient solution. So, so yeah, I understand why we are using two pointers here and why we are declaring variables and how we are declaring pointers in this case. Fine. Now let's move to the next slide. What would be our step three? Now let's start with the step three. Start a loop to compare heights. Fine. First condition is given as in the loop I is less than j, the while loop will continue. Why I less than j? If you haven't noticed, we are coming from two directions, right? And whenever j crosses I or I crosses j, it means that the complete iteration is done, right? That is the why. That is why we are using I less than j. And now here, calculating the area. If you have, if you can understand that whatever area was stored previously, we will take that, we have to compare it with that, right? And the current pole height of the pole, it could be from the j index or from the I index, whichever is the minimum one, and you multiply it with j minus I, which will be the distance between them. So it is basically length into breadth, right? Now the container height is limited by the shorter line, right? We are using maximum here just to store the value of comparing the value of the area with the current calculation and the previous area stored, right? Now coming to step 4 here. Okay, what are the conditions? If height of I is less than height of j, consider this is the pole in height and this is the pole in j. Fine. What we do? We take this height, fine, and put it here in this formula. So it becomes height of I multiplied by j minus I. Fine. Okay. Because it becomes this. After that, we moved I plus 1. Why we are moving I plus 1? Because now we got the area. Now we are looking for any I which is greater than the current I, right? So we move I plus 1. This is a reason increasing the shorter line might increase the area. Now we check if height of I is greater than height of j. Now if this is the thing. For example, after coming a few indexes ahead, we find out that uh, this height is smaller in the j path. Consider this. So what we do? We take the minimum index value, which is j in this case, because and we put it here again. So it becomes height of j into j minus I, right? And we decrement j. Why we are decrementing j? To look for any values which is look for values of any pole which is greater than the current pole. Consider in the future we get a pole greater than this, so we could use that. So area becomes this way. Now there could be a condition in which both the height could be same, right? What we do? Taking either of the pole solves our solution, and we have to move both towards each other since both are the same height and both out of both has been one of any of them has been used. If both lines are equal, moving both pointers allows to explore to new combinations, right? So this is the step 4 of the conditions why we are using. I hope you understood these conditions, and I also hope that you understood the formula. And after that, after step 3 and step 4, we will return the maxi variable which stores the final output. Fine. I hope you understood the complete approach, and I will request you, if you haven't understood or have any doubt, please start from the intuition and understand how we have come to the intuition of using two pointers and then come to the approach and try to understand it. Now let's move to the next slide. The code is exact copy of the approach discussed. Now let's understand it line by line. We are storing the length of the height array. We are initializing the two pointers I and j, which starts from 0 and which starts from last. Then we're declaring maxi variable with negative infinity value since we have to find the maximum area. Okay. These are our main conditions. If height of I is greater than height of j, we take the minimum height, which is height of j, and the distance between them, and we store the max, compare with the maximum value, and store the result and decrement the j value towards the I. If I is smaller than j, we take the height of I, do the distance calculation, and find the area, and compare it with the previous one, and move towards the j. If both height of j and I is equal, we could take either of the index value and calculate the height and move both of them towards each other in one go. And at last return the maxi, which is the stored value. Now the time complexity is O of n because we're iterating the array only once of length n from both directions. Fine. And it is of length n. And space complexity is 1 because we are not using any data structures such as list, stack, or queues or any other to store the output, right? Instead, we are just storing the index value. Instead, we are storing just a value which takes a constant space. Fine. I hope you understood the code, and now let's move to the next line. Now, since we have the understanding of the code, let's look at the dry run of the example. Fine. Let's make a pole here or a distance between them. Let it be 1, 8, 6, 2, 5, 4, 8, 3, and then 7. Fine. Okay. Now, our pointer starts from this part first and the last. Now, second thing was comparing both the values of the indexes. Right? So let me write it here as let me make it I. This is I. This is j. Right? Maxi is right now negative value. Right? Negative infinity. Now, minimum of this I 1 and 7 is 1. Right? 1. Distance between them is j minus I. So if we check 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So if it is this, so it will be 8 minus 0, fine. We get 8 as the output. So our negative value get replaced in maxi to 8. Okay. Now we move ahead. Since now i's value is 1 and compared to 7 it is smaller, so we will move I from here to this index. Okay. Now comparing 8 and 7, j value, height of j is smaller than height of a. If we could see here, height of j would be smaller than height of I, and height of I could be smaller than height of j. If height of j is smaller, we decrement j. If height of I is smaller, we increment I. So in first case, we incremented I. Now we could see that j is smaller. So we will take 7. 7 into distance between them, which is 8 minus 1 gives us 7, right? 8 minus 1 is 7. So we get output as 49. So it compared to the maxi, comparing with maxi variable here, which we are comparing with previous one, we will replace this with 49 and store it here. And we will move j from here to last second index. Now we will compare both. Now 3 is smaller and distance between them is 7 minus 1 gives us 6. 6 3 ja 18. 18 is not greater than 49, right? So we will move j or decrement j towards I. Now we could say that both values are similar, right? What we will do? We will we will remove this. So since both values are same, we could take any of the values. We will and find subtracting it 5, we get 5 and output is 40, right? It is also smaller than 49, so we cannot take this. So we will increment I to this value and we will also decrement j because both values are similar. Now comparing 6 and 4, 4 is smaller, multiplied by 5 minus 2 gives me 3. 4, 3, 4 into 3 gives me 12, which is also smaller than 45, so it won't be considered. Again, we have to move j towards 5 or the decrement j towards the value 5. If we compare, 5 is smaller and distance between them is 4 minus 2 gives us 2, so it's 10. This is also not acceptable, so this is less than 49. Again, we move j to 2. 2 is smaller, distance between them is only 1, so output becomes 2. So this is also not considered because it is smaller than 49. Now we move j here and it violates the condition I less than j. So we break out of the loop and we return max equals to 49, which is our output. I hope you understood this diagram and how the pointers are moving and how the conditions are getting satisfied and unsatisfied. If you still have doubt and have not understood any part of the problem, I will request you to go and read out the question again, understand the equation, how we come up to using two pointers, then the approach, and then try dry running any 2 3 examples of your own. And I am pretty sure you will understand how the logic is working. Now let's move to the next slide. Now since you're familiar with the problem and solution, let's move to the lead code and code the solution. Okay, we'll declare n as variable which will store the length of the height array. We will initialize pointer I equals to 0. It will move from left hand side left, j equals to n minus 1 from right, maxi variable with float of negative infinity to store the maximum result, and while I is less than j, if height of I, okay, if it is greater than height of j, in maxi we will store the maximum of maxi or height of j because j is smaller in height into j minus I, find the distance between them and decrement j in loop in search for other value greater than j. Now else if height of I is smaller than height of j, in that case what we'll do, vice versa condition, vice versa. We will have the maxi here, previously stored surface area compared with the current area which we get, and we increment the height of increment I, look for other poles like greater pole height. Okay. Now in else case, maxi will be max of maxi, taking either of the height, and since both are same in this case, but we have to increment I also and decrement j also to look for other heights. At the end, we will return maxi. Okay, I might have missed something here. Okay, the reason which we are getting time rate exceeded is instead of I1, I have written here I. Now let's run it again. Okay, we got cleared with the test cases. Now let's submit the solution. We successfully submitted our solution. Now, code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.